Hi guys. Um, Today we're going to be taking a look at a new topic. The new topic is two-column congruence proofs. Now, I've been working with you for the last week or so on figuring out how to determine if triangles are congruent. Let's take a look at the example here. How do we know if these triangles are congruent? We need to explain why we answer it the way we do. Well, if I look at this problem, I am given in this problem a statement that segment AB is congruent to segment CD. How would I show that in the picture? Well, I would have to mark it. Segment AB congruent to segment CD. We show segment congruencies by using the hash marks. Okay, so I just marked that in the picture. What else did it tell me? Well, it also told me that segment AD was congruent to segment CB. So again, I can show that by using the hash marks, but this time I'm going to use two hash marks because it's a different congruency statement. So the only difference here is that I didn't actually mark the figure and give it to you marked. This time you had to take the information and mark it. But now that we have it marked, how would we determine if these triangles are congruent? Well, is there something that's congruent that's not marked that we can mark? I think so. If you take a look, we've got a segment BD that is a part of both triangles. It is a shared side. So if I mark that congruent, I did that using something called reflexive. You guys know this. We've been working with reflexive quite a lot. So now I have several things marked in my picture. Is this enough markings to say the triangles are congruent? Yes, it is. We can say they're congruent by side, side, side. So I would be able to say triangle ABD is congruent to triangle CDB by side, side, side. Now remember that when you make those triangle congruencies, you have to put them in matching order. A matches to C. If I look at where the angle B is up here, the angle B is where line 1 and line 3 meet together. So that would be the angle that is at the D in the other triangle. So we've been doing this. We know how to determine if triangles are congruent. How is what we're doing now going to be different? Well, it's just in the way we write it. What we're going to be doing now is we're going to be writing this in something called a two-column proof. A two-column proof does exactly the same thing, it's just written in a different way. If I take a look at this particular proof, you'll see it is exactly the same given information and picture. So, my given information, segment AB is congruent to segment CD, and segment AD is congruent to segment CB, is the same. That information is given. Our given information is always our first part of our two-column proof. So all I'm doing is writing down the given information as the first step of my two-column proof. Now, how did I know that those segments were congruent? Well, I knew they were congruent because that was given to me. So that's all I have to say. That's the reason I know they're congruent. Now that I've written these congruencies in my proof, I can mark them in my figure, just like we did before. The only difference is we're putting the information in a two-column format, and we're marking the figure as we put it in the two-column format. Okay, so now I've got my given information marked. Well, what was the next thing we said when we did this problem without the two-column format? Well, we said that we had something that was congruent to itself. the segment BD was congruent to the segment BD, and we knew that was true because of reflexive. The only difference between the way I'm writing it here and the way I wrote it before is that I'm putting it in two-column format. All right, once I wrote it in the proof, I marked it in the picture. Now, is that enough to say that the triangles are congruent? Yes, it is. So, I can now say that triangle ABD is congruent to triangle CDB, and my reason would be side, side, side congruency. Notice, and this is really, really important for you to notice, my given information was statement number 1. Very important to know that the given information was statement number 1. My prove statement is always my last statement in a two-column proof. Please make sure you do that every single time. It's an easy thing to do. Make sure you start with your given, make sure you end with your prove. All right, let's take a look at another example. If I take a look at this problem, if I were just thinking it through like we have up until now, I want to know, are these triangles congruent? Well, what do I know about the triangles? I know that segment AB is parallel to segment D or ED. That is given to me right here. What else do I know? Well, I know that segment AC is congruent to segment EC. That was given to me right here. I've now marked my figure based off of my given information. Well, I've got to think, what do I know about parallel lines? If I have parallel lines, there are certain angle relationships that are going to be congruent. Parallel lines, I know that I'll have corresponding angles congruent. If I have parallel lines, I know I'll have alternate interior angles congruent, and I know that I would have alternate exterior angles congruent. Well, do you see any corresponding alternate interior or alternate exterior angles in the picture? I do, because in the picture, I see my two parallel lines connect with another line to make something that looks like a letter N. Remember, alternate interior angles always either make an N, a Z, a backwards N, or a backwards Z. So that means I know that this angle right here has to be congruent to this angle right here. So angle A would be congruent to angle E, because parallel lines means alternate interior angles are congruent. That's one of the rules that we learned at the beginning of this unit. Was there anything else I know is congruent? Yeah, you see it. Vertical angles. I've got vertical angles right here in the middle. Notice I'm marking those with 2 little arc marks instead of 1 because I've already used the 1. Okay, so how do I name those angles? Can I call them angle C? No, I can't call those angle C. There's a bunch of angles that have C as a vertex. So I can't use just a letter C. I'm going to actually this time have to use 3 letters. If I start at A, go to the C, and turn around to the B, I will have traced the angle. On the other side, if I start at E, I go to the C, turn around and go to the D, that will have traced the angle on the other side. And those I knew were congruent because they were vertical angles. Okay, good. So now that I've marked my figure with everything I can mark, are these triangles congruent? The answer is yes. I now know that triangle ACB is congruent to triangle ECD by angle, side, angle. Okay, so we've been doing problems like that over the last week or so. How do I take this and do the new concept? Whoops. Well, to do the new concept, I'm just changing the way I write it. So what was it we said would always be our very first statement? Our very first statement is always the given. So I'm just going to come over here and write my given into my proof. My reason that I know that's true is because it was given to me. Okay, so I've got AB parallel to DE. I just marked it. AC is congruent to EC. That is also marked. What else did I say I knew? Well, I said the parallel lines gave me angle A congruent to angle E because the parallel is going to let me say alternate interior angles are congruent. Okay, so I wrote it. Now I can mark it. And what was the next thing that I said? Oh, yes, the vertical angles. Angle ACB is congruent to angle ECD. And I knew that because the vertical angles were congruent. Okay, I wrote it in my proof. Now I can mark it in my picture. Okay, so what else did that let me know? Well, now that I'm looking at my markings, I can clearly see the triangles are congruent. So I know triangle ABC is congruent to triangle EDC, and my reason is going to be angle, side, angle. Notice when I wrote that triangle congruency, I wrote the triangle congruency in the same order as what I was trying to prove, because I know my proof statement has to be the last statement in my proof. I know the given information is going to be the first statement in my proof. Okay, so again, that's another example of a two-column proof. What about this one? What can I say about this one? Are these triangles congruent? Okay, well, is there anything in the picture that is congruent that is not marked? Oh yeah, we've got those vertical angles going on again, don't we? Okay, so angle ABE would be congruent to angle DBC. And I know that because vertical angles are congruent. Well, now that I've marked it, and I've told you why I marked it, I can see that I have enough to say that triangle ABE is congruent to the triangle DBC because of side angle side. Well, this is the way we've done it over the last week. All we're going to do is change the way we write it. We're going to do it in a two-column proof. So what did I say our first step would always be in a two-column proof? The first step is always going to be my given statement. So I know segment AB is congruent to segment DB. I also know that segment CB is congruent to segment EB. I know that because my given information is my first statement in a proof every single time. How do I know that's true? I know it's true because that was what was given to me. Okay, so that was statement 1. What was the second thing we did when we did this on the previous screen? Oh, we identified that we had vertical angles. All right, so I know angle ABE was congruent to the angle BBC because vertical angles are congruent. All right, just like on the previous screen, except I just am writing it into two-column proof instead. So was that enough to say that the triangles were congruent? It was. So I know triangle ABE is congruent to triangle DBC, and I know that my reason is side angle side. Notice the last statement of my proof has to match my last statement of what I'm trying to prove. Okay, let's look at another. Are these triangles congruent? Well, do you notice anything that is congruent in these triangles? I do. They have a shared side right here in the middle. When we have a shared side, I know that that shared side has to be congruent to itself by reflexive. So I marked it, and I'm telling you why I marked that congruency. Well, look at what's marked now. I have right angles. What are the pieces that are marked congruent? Well, it looks like it's a side that is touching my right angle. You see it? It's touching the right angle. That means that that side is called a leg. All right? Okay, well, what is the other side that is marked congruent? What do we call this side over here that is marked congruent? Is that a leg? Does it touch the right angle? Doesn't look to me like it touches the right angle. It looks to me like it's across from the right angle. So what do we call that piece? We call it a hypotenuse. Right? Okay, in our other triangle, don't we have the same pieces? So that means I can say triangle FGH is congruent to triangle IHG by hypotenuse leg. Okay, let's put it in a two-column format. Statement 1. What would statement 1 be? Oh yeah, it's got to be that angle, FGH is congruent to angle, oh, I'm sorry, I'm going back, my mistake, I'm fixing it. It's angle FGH and angle IHG are right, and segment FH is congruent to segment GI. Okay, where did that come from? That was my given information. So that is what goes in my first statement. What is the reason for writing that? Because it was given. Okay, what did we do next in our proof? Well, on a previous screen, when we looked at this without the two columns, we brought up the fact that, hey, we've got segment GH that is congruent to segment GH, and that was by reflexive. Good. Okay, so now I wrote it. Now I'm going to mark it in my picture. That's going to help me look at it and say, hey, now that I know that, I can finally say there's enough marking in my picture for triangle FGH to be congruent to triangle IHG. Okay, and what was my reason for that? It was hypotenuse leg. Notice the prove statement is my final statement in my proof. Okay, let's look at another one. I think this may be the last one. If I take a look at this one, okay, I notice that my information tells me that segment XT bisects angle SXR. What does it mean to bisect? Well, I'm bisecting the angle SXR. Bisect means that it breaks it into two congruent pieces. So I know the two angles right here in the middle have got to be congruent. That's what it means to bisect. So I know that angle SXT has got to be congruent to angle RXT. And I know that because of the definition of bisect. Okay. Well, what else do we know in the picture? Well, don't I know that segment TX is congruent to segment TX? Okay. That's right here in the middle. Okay. If that segment is congruent to itself, I can mark it. Well, look at your markings. What do we know? Well, I forgot to say, why was TX congruent to TX? That was by reflexive. Okay, so what do we know now? Don't we know the triangles are congruent? I know that those two triangles have to be congruent now. Triangle SXT is going to be congruent to triangle RXT, and my reason is angle, angle, sine. All I need to do now is convert that into a two-column proof. What you're going to see is this two-column proof is called a fill-in-the-blank proof. I've already given you all of the statements. You just have to tell me what the reasons are. So who can tell me what let us say that angle S was congruent to angle R, and that segment XT bisects SXR? How did I know that was true? Well, every other problem that we've had, our very first statement we knew was true because it was given. Good. Okay. How did we mark our picture? Well, angle S congruent to angle R, we're going to mark with one single curve. And I can't mark anything yet for XT bisects because I don't have a symbol for bisect. But what does it mean to bisect? We said it broke it into two things that were the same size, that were congruent. So I know angle SXT is congruent to angle RXT because that was the definition of bisect. Good? All right. And then what was the next thing that we said? Well, we said that XT was congruent to XT. So that's this segment right here in the middle. What is our reason for saying that that is congruent to itself? Oh, that's the reason is reflexive. Okay, so what makes the triangles congruent? The triangles are congruent by angle, angle, sine. What do you notice our last statement is? Our last statement matches the proof statement. That has to happen in every two-column proof. All right, so here's one that I'm hoping you will do on your own. I want you to try to write the two-column proof for this problem. And I will see you guys at our next class session.